This video will review learning targets 26, 27, and 28, which involve using three different functions that have to do with the normal distribution. One is the normal PDF, one is the normal CDF, and one is the inverse norm. So I'll do one of each of those types of problems and sort of talk about how you can tell the difference between when you should use PDF versus when you should use CDF and when you should use inverse norm. So learning target 26 is using the normal distribution PDF. The normal distribution PDF allows you to calculate an approximate probability that a data point will be around a single particular value. So let's do an example of that. So in this problem we have that the snowfall Boston gets in a year is normally distributed with a mean of 48 inches and a standard deviation of 10 inches. Find the probability that we will get about 50 inches of snow this year. And then it says to write down both what you plug into your calculator and a decimal answer rounded to 2 decimal places. So I can tell that I should use normal PDF here because I'm looking for a probability that a data point will be around a single value. So the amount of snow we get this year is going to be around 50 inches. So when you're looking for an approximate probability that a data point will be around a single particular value, you'll use the normal distribution PDF. So when you use the normal PDF on your calculator, I'll show you how to in a second, but you need to plug in 3 values into your calculator. The first value is the value that you are interested in the probability of, the value that you want to know the probability of getting that value. The next number will be the mean of your normal distribution, and the last number will be your standard deviation. So in this case, we have a mean of 48 inches, and we have a standard deviation of 10 inches. The 10 will be the last number that goes inside the normal PDF. The mean of 48 will be the middle number. So now we need to use our calculator. Our calculator sort of stores this normal PDF function, and so we need to use our calculator to actually calculate the normal PDF. So let me show you what buttons you need to push to get to the normal PDF. So you're going to hit the second button first, and then you're going to hit this button here, this VARS button. See how it says DISTR at the top? That stands for distribution. So you're going to hit second, and then this button here. And when you do that, you should have a screen that looks like this. Now, if you notice, the first 3 options are normal PDF, normal CDF, inverse norm. For this problem, we're using normal PDF, so you want to just have it highlighted on 1 and hit enter. Now, depending on how new or old your calculator is, you may need to just input these 3 numbers with commas in between them, the way that I have it here. Close the parentheses and hit enter. And by the way, the comma is right down here on your calculator. So you would go to second distribution. For the normal PDF, you would hit enter, and then you would type in this case, you would type in 50, and then the comma, and then 48, comma, and then whatever the standard deviation was, 10. So then you would type in 10, close the parenthesis, and hit enter. And if you do that, give me just a second to type it into my calculator. If you do that, you get about 0.04. So as a decimal, that's our probability. If you wanted a percentage, this would be around 4%. So once again, for a normal distribution, we want the probability that a data point will be around a single particular value. Now, the normal CDF instead allows us to calculate the probability that a data point will lie within a range of values. So PDF, we're interested in the probability around a single value. CDF, we're interested in the probability a data point will lie within a range of values. So here's an example problem. The snowfall Boston gets in a year is normally distributed with a mean of 48 inches and a standard deviation of 10 inches. Find the probability we will get between 50 and 60 inches of snow this winter. And once again, we want to write down both what you plug into your calculator and a decimal answer rounded to 2 decimal places. So since we can see that we have a range of values here, we know we want to use the normal CDF. So now in the normal CDF, you have to input 4 numbers. So the first one is going to be the lower bound of your range of values. The second number will be the upper bound of your range of values. The third number will be your mean, so in this case 48. And then the last number will be your standard deviation, so in this case 10. So the normal CDF requires you to input 4 things into the function. You need to first input the lower bound of the range of values, the upper bound of the range of values, the mean, then the standard deviation. Now you'll see some problems where it'll ask you for example, find the probability that we get over 50 inches of snow. And the way that you would handle that is you'd put 50 as the lower bound, and then for the upper bound, you'd put some really, really huge number where like it would be completely unreasonable to get more than that number of inches of snow. So like put in like 1,000, for example. So that's how you would handle that situation. And then similarly, if it said instead get below 60 inches of snow, we would keep the 60 as the upper bound, and for the lower bound, we would put some teeny, teeny, tiny number where it would be completely unreasonable to get less than that amount of snow in a winter. So now let's talk about how to actually calculate this on our calculator. So we're going to approach it the same way as we do the PDF. So we need to hit the second button and then the VARS button, and that will bring up this screen here. Instead of highlighting the normal PDF and hitting enter, you instead want to hit, arrow down so that number 2 is highlighted and hit enter on that. And then you're just going to input these 4 numbers separated by commas. Once again, the comma button is right here. If you have a newer calculator, it might just have a screen where it asks you for these 4 numbers separately. So there might be, a line that asks you for the lower bound, a line that asks you for the upper bound, a line that asks you for the mean, and one for the standard deviation. So depending on how new your calculator is, it'll look slightly different. But the idea is that you have to type in these 4 numbers here. So let me actually do that on my calculator. And I got about 0.31. So that is the probability that we would get between 50 and 60 inches of snow this winter. If it had asked for a percentage, it would be around 31%. So finally we have the inverse norm question. So an inverse norm allows us to find the cutoff value for the top X% of a population. So if you're interested in what's the cutoff between the top 10% of test scores and the bottom 90% of test scores or something like that, the inverse norm allows you to calculate things like that. So here's an example problem. We're still talking about snowfall in Boston. But the question is, how much snow would we have to get to be in the top 20% of snowiest winters? So Since we're talking about sort of trying to find the cutoff value for the top 20% of snowiest winters, that's a hint that we need to use our inverse norm function, because the inverse norm function allows us to sort of find a cutoff value for the top however many percent. So we will use our inverse norm calculator, or function on our calculator. And the inverse norm requires you to input three things. The last two are the mean and the standard deviation, the way that you're used to. The first one is a way of telling the calculator what, are you interested in the top 20%? Are you interested in the top 80%? Are you interested in the bottom 10%? We need to somehow tell our calculator that information in the first number. So here's how we're going to do it. I'm just going to draw myself a quick little picture. So here's my little normal distribution that represents snowfall. And I'm interested in the top 20% of winters, and I want to know what is the cutoff value that sort of divides our normal distribution between the top 20% and the bottom 80%. Now, your calculator just had to pick sort of, when they wrote the programs for your calculator, they sort of just had to make some arbitrary decision whether it would take in this number to the right or if it would take in this number to the left. And for whatever reason, the calculators are programmed so that they'll take in the value to the left always. Always, always, always. So you always have to sort of at least imagine a little picture like this and imagine sort of what portion of the distribution is to the left, not to the right. Even if it's asking about a top 20% question, you still have to think about sort of what portion of the graph is off to the left. Also, you have to input it as a decimal, not as, 80. Don't put in 80. You have to put in the decimal value, 0.8. So then the second number will be the mean, 48. And then the third number will be the standard deviation, 10. So once again, into our inverse norm function, the first value sort of tells you the portion of the graph off to the left of whatever cutoff value you're looking for. The second number tells you the mean, and the third number tells you the standard deviation. So once again, to find our inverse norm function, we are going to go to second, distribution. When this screen pops up, notice the third one down is inverse norm. So you're going to have to arrow down and hit inverse norm. And then you're going to put in these numbers, and let's see what we get. So I got 56.42 inches. So if we get more than 56.42 inches of snow, then we would be in one of the top 20% of Boston winters. So let's just quickly review. If you want a probability that a data point on a normal distribution falls, it's sort of around a single particular value, you'll use normal PDF. If you're interested in the probability that a data point will fall within a range of values, you'll use normal CDF. If you want to find like the cutoff value for the top 10% or the bottom 15% or something like that, you are going to use the inverse norm. And just make sure that whenever you're doing these problems that you are both writing down what you're plugging into your calculator, including whether you're using inverse norm, normal CDF, or normal PDF, and these numbers, and then you're also giving a decimal answer as your final answer.